Okay, good morning, class. Today we are working on CO22. I can find the prime factors of a number using prime factorization. So we talked in, Bennett, I'm recording right now. Can we not make noise, please? We talked on our last objective what those prime numbers are. We just reviewed that. Those prime numbers are when we can't break our numbers down anymore. Right? The only numbers we break it down into is itself and 1. So we're going to be breaking numbers down into all the primes that we multiply together to get to it. It's called prime factorization. So DNA is a person's genetic code. What makes them who they are? What makes you uniquely you? Numbers are the same thing. What makes a number that number? What can we break it down to? You break down your genes into your genetic code, your DNA. You can break a number down into the primes that we multiply together. So why would we be defining a science term like DNA in math? Because numbers have that genetic code that make each of them unique too. This code is a number's prime factors. We talked about those prime numbers. So again, the definition is the prime numbers that multiply to make a given number. So when we had 12, think about the prime numbers to make 12. We break it down, or 9 is easier. 9 we can break down to 3 times 3. Please stop. Because I see her watching you and it distracts me. So 9 we break down into 3 times 3. 3's are prime numbers. We can't break the 3's down anymore. So those prime factors would be 3 times 3. We're going to see how that works for other numbers. So you can use a factor tree to make the prime factors of a number. It's going to look like a Christmas tree, which is Gianna's favorite time of the year. We have already decorated our house for Christmas, so we want to make those Christmas trees. So let's see how we can make our Christmas trees for our prime factorization. At the very bottom, if you multiply all the primes together, your product should be the original number. So let's see how this looks. Let me move this up. Our first number is 12. What factor buddies could I break 12 down into? Bridget?
Oh, like 6 and 2.
Yeah, 6 and 2. So I'm going to break it down. 12 can get broken down into 6 and 2. Can I break the 6 down any more? Adeline? And? Yeah, I can break that 6 down into 2 times 3. Can I break my 2 down over here anymore? Can 2 get broken down? No, 2 is our first prime. So I'm going to write that 2 again. So I have 6 times 2. That 6 is broken down into 2 times 3. That 2 stays a 2. So my prime factorization would be 2 times 3 times 2. If I put that into my calculator, would that equal 12? Does anybody want to check it? Go ahead and check with your calculator. 2 times 3 times 2. Do we get 12? Thumbs up when you find your answer. I got a thumbs up from Kylie. Thumbs up from Bennett. 2 times 3 times 2 is 12. Is this the only factor tree we could have made for 12?
Yeah. No.
No. Why? What else could we do, Kellen? What else could I break that 12 into? 4 times what? 4 times 3. Can I break the 4 down anymore? Yeah, what can I break a 4 down into, James?
2.
And?
5.
2 times what?
2 times 2.
2 times 2. Can I break my 3 down anymore? Nope, that's a prime. So look at that. I still have the exact same primes on the bottom. So it doesn't matter Which factor, buddy, I originally break it down into? I break it down, I keep going down to the primes. I'm going to come to the same primes no matter what. 2 times 2 times 3, 2 times 3 times 2. It's the same prime numbers. There are 2 2s and 1 3. We multiply them together and we get 12. Okay? So it doesn't matter which factor, buddy, you use to start it off, as long as you keep going all the way down to the primes. So let's look at our next one. 15 and 3. What can I break that into? Adeline? 5 times 3. Oh, I'm going to circle my primes so I know. Notice how I put that multiplication symbol in there because we want to multiply all those primes together. So now I have my, it looks like a little factor tree so far. Can I break down the 5 anymore? Adeline's shaking her head no. Why no, Adeline? Because it's a prime already. Can I break the 3 down anymore? No, 3 is a prime. So that is my prime factorization. I cannot break either of those down. Let's look at our next one. Oh, wait. I did not read all the directions. I'm off my game today. Technology is confusing me. It says, then write at least 3 factor pairs if applicable. So here we had 6 times 2, 3 times 4, and we could do 1 times 12. What could I write for 15? Adeline? 5 times 3. 1 times 15. You can always do 1 times the number. So this one, I could only write 2. There are no other factor pairs for 15. There's just 2 of them. But for a number like 12, we can get to those 3 factor pairs that you multiply together to get to it. Let's look at 27. What can I break 27 into? What factor pairs? Maddie? 9 and 3. Can I break the 9 down anymore? Sarah? 3 and? Yeah, I have to put both numbers that I multiply together. So I can't just put 3. I have to put 3 and 3 because that's what I'm multiplying together. That's the factor buddies. Can I break my 3 down anymore? No, 3 is a prime. So for my prime factorization, I have 3 times 3 times 3. It's everything on that bottom row. So I have to have that 3 listed 3 times. 3 times 3 times 3 is 27. Now I have to put my factor pairs. What factor pairs can I put? Sophie? 1 times 27. What else could I put? 9 times 3. Is there another factor pair that I could put? There is. What? 3 times 3 is only 9. And I need to get to 27. Adeline? Yeah, this is just like 15. There's only 2 factor pairs for this one. Let's look at 40. What could I break 40 into, Bennett? 10 and 4. Can I break my 10 down anymore? Adeline? 5 and what? 5 and 2. Can I break my 4 down? Kylie? 2 and 2. Now I go to my next row. Can I break the 5 down anymore? Nope, 5 is a prime. Can I break my 2 down? Nope, 2 is a prime, 2 is a prime, 2 is a prime. So what am I going to write for my answer? Remember how we're circling our answer. What is my answer going to be, Lila? Yeah, so I have it written this way, so I'm going to put 5 times 2 times 2 times 2. because I keep it in order. If you had 2 and 5 going flipped, that's fine too. It's going to be the same numbers as long as your answer has 1 5 and 3 2s that you're multiplying together. It doesn't matter the order, as long as you have all the primes listed. Bennett, do you want to do a factor pair? Nope. 5 times 2 is 10. I need a factor pair for 40.
5 times 2 times 4.
Nope. A factor pair. Pair means 2. What 2 numbers could I multiply together to get to 40? Nolan?
5 times 7.
5 times 7 is 35. Try again. 5 times what, Nolan? 5 times 8. I could have used 5 times 8 as my first 2 numbers. What's another factor pair? Hudson?
20 times 4.
20 times 2. What's another factor pair? Natalie?
1 times 40.
1 times 40. What's another factor pair? Jack?
10 times 4.
10 times 4. Are there any other factor pairs? I don't think so. So this time we could find 4. Said write at least 3. I like to write as much as I can. This time I could go up to 4 different factor pairs to get to 40. You have to have at least 3 listed for this one. Any questions on how we're doing today's assignment? So we can see we have 2 more rows. I need to see your trees. I should not just see your prime factorization at the bottom, what you're multiplying together. I need to see your trees where it's listed, broken all down into those prime factors. Then I need to see all your factor pairs listed. So we're making our little Christmas trees, going all the way down to the primes. Make sure you break it down far enough. If you don't break a number down to its primes, it's going to be wrong. So you couldn't have just stopped at 10 and 4 and said that's my prime factorization, because they're not broken down to prime numbers. They all need to be broken down into primes. If you have one number that needs to get one composite to break down in one prime, remember to bring that prime down so it looks like a tree. So then you just take all the numbers at the bottom. Nolan? You can use the calculator to check your answer. I'm fine with that. On the test, you won't be able to do that. So you can for this, just to make sure that you are doing it correctly. Just know on the test, you're just doing the prime factorization. James?
I did not 101. I did 50 times 2 when I broke the 50 down in, never mind.
Okay. Any other questions? All right, when you are finished with today's assignment, remember we don't have a con assignment this week, so check. I had some friends that didn't get con done last week. So check to see if you have a missing in Blackbaud for your Khan Academy. Get your con done. Math packet number 3s are due today. Get that turned in. Shields of Faith are due. We need those on our lockers. Get those turned in. If you are all done with all of that, Gianna, do you have packet number 4 all stapled? For Math 6.
Yeah.
I will be passing out packet number 4. It's due in 3 weeks, right before Thanksgiving. So that Tuesday before Thanksgiving, packet 4 will be due. So everybody has math or your theology shield of faith to work on. Let's get it done. If you're watching this from home, I hope you are well. I hope to see you soon. Don't forget to like and subscribe. Have a wonderful day.